Hi, I'm Paul Beckwith. I'm at the University of Ottawa, and I'm researching abrupt climate change. The big question on everybody's mind is what's going to happen with the El-Niño this year. About a month ago, Kevin Trenberth did a couple videos talking about his views on it, and he mentioned that the ocean temperatures reached 6 degrees Celsius above normal, 150 meters down in parts of the Pacific. Um, this something similar to this was seen in the large El Nino in 97, 98, which killed about 20,000 people and caused about $97 billion worth of damages. The more weaker El Ninos, that temperature might increase about 2 degrees Celsius. So 6 degrees is a very strong indication that this El Nino is going to be very strong. Alex Smith, in his program EcoShock Radio, interviewed three different climate people, meteorology people about the El Nino, about what was going to happen. So there's a lot going on. So what I'm going to do is just look at data, what's going on in the Pacific today, right now, and what can we say about the El Nino from that. So basically, first of all, the jet streams. What's happening with the jet streams at 250 millibar. It's the winter in the southern hemisphere, summer in the northern hemisphere. So the temperature gradient is lower between the equator and the northern hemisphere. So the jets slow down, become wavier, and they're far north. And we see this very fractured pattern, which is causing lots of torrential rain events and unusual extreme weather events in the northern hemisphere. It's very, very warm water across the equator. So there's a large temperature gradient to the southern hemisphere, which is winter there. So the jets are stronger, but they're also very, very wavy. If we look at some of the speeds in the northern hemisphere, this is 180 kilometers an hour wind speed. This is 160. And then down the southern hemisphere, we're reaching 300 kilometers an hour plus. So these things are really moving because the temperature gradient is larger. So the sea ice is growing because of katabatic winds pushing it offshore, freshening. You know, the ocean's warm underneath, so there's still melt. So there's more fresh water, freezes at a higher temperature. What else is going on? What else can we say? Okay, so what this is here is going to lift the camera up because there's a bit of glare. Okay, so this is the relative humidity. So we're 100% here, you know, 97%. So it's raining in those regions. Water, like I say, is very warm across here. But across this basin, the relative humidity is typically high 70s, low 80s percent. Because it's very, very warm air, it can hold a lot of moisture. In terms of clouds, we can see what's happening with the clouds in this region. So in all these images, this is South America here, this is Australia, Indonesia here, this is just the Pacific Ocean at the equator. So what this number is kilograms per square meter of water vapor that's inside clouds. So there's some water vapor, you see these clouds here, there's water vapor, you know, in these regions. There's almost no cloud formation. We certainly don't see, you know, the water's a bit warmer there, there's some clouds, it's also warmer up here, there's some clouds, but we don't see the typical intertropical convergence zone clouds because it's just very, very warm, so we're not getting much formation of clouds. I mean, this is not a lot of water vapor, this is the temperature across the, you know, and you can see the wind patterns here. So this is the parts of the trade winds, the southeast trade winds, the northeast trade winds. But we're getting other things happening, which I'll show you in a minute. But generally, the air temperature is about 28 degrees, something like that. It's a bit warmer over here, where the water's really warm. It's also a bit warmer up here where the water gets butted up against the continents. And then of course on the continent itself it's much warmer, 36.5 degrees, and it's very warm in here in the well, it's about the 27 again. It looked warmer there. Okay, so this is the sort of thing that we're seeing there. I'll go back here. Okay, so what's going on with the water temperatures now across the Pacific? Let me adjust this camera. My hand's getting a bit tired here. Okay, so there we go. A little bit of shakiness. Okay, so what's happening in the what's happening with water temperature? Now I'm getting a bit of glare, so I'll just go with holding it up. Okay, so there we go. So this is the temperature of the water. So what do we have? The purple sea surface temperature, 31 degrees. Okay, so we're well over 30 degrees up in this purple region. And then this is tracking across the Pacific. You can see the some currents going across here. So this is high 20s, high 20s. When we get over here, close to 30 degrees again, so where the water is piling up. The water, since the last, there's been two really powerful El-Niños in the last 140 odd years, as Trenberth was saying. 82, 83, really strong one. A lot of the heat went into the atmosphere. Then the ocean had about 15 years to build up heat, and then it was all released in 97, 98, or a lot of it was released with that massive El-Niño, which had huge effects globally. 20,000 people were killed. It caused $97 billion worth of damages. So what's happened since 97, 98? Well, sea level has risen about 20 centimeters here, much higher than the global average. About 10 millimeters a year, in fact, which is 3 times faster than the global average sea level rise. So 20 centimeters higher here, lower here. Eventually that has to break. That water has to come pouring across, which it does so in this sort of Kelvin wave, which we're seeing. So it's coming across, and then the stations in here which monitor water temperature, when they read 0.5 degrees higher than normal for 3 months on end, then you can declare an El-Niño. So that water is coming across. So what we've seen is the sea level rise here in the last number of months has been about 10 centimeters. So about half of that water head is sloshed across, so it'll all keep coming. If we look over off here, you know, the water of course is cooler. This will be about 20, this will be about 10, you know, to give you an idea of the colors. So the warm water is coming across north of the equator because it's shifted from the equator because it's summer here, winter here. What about the temperature anomalies? Okay, so these are the temperature anomalies. So over here, we're talking a couple degrees warmer than normal. You know, over all across this basin, you know, 1.5 degrees, you know, 0.8 degrees, 2 degrees. Over here, 2.5 degrees warmer than normal. So the water, you know, this is definitely El-Niño happening here. Over here, this is unusual. This isn't normally part of an El-Niño. We get, you know, this has been persistent here, you know, over the winter, over the summer. It's the reason why California, a big part of the reason why California has a massive drought here. And that these blue regions are, you know, colder than, so we've got the colder areas than normal here, and there's a cold tongue here, which is typical. The water kind of breaks off, and there's a Pacific cold tongue here. What else do we have? Okay, so we looked at that. Oh yes, so this is telling, okay, because this is the total precipitable water. So in these regions here, 56 kilograms per meter squared. Notice that we don't have the clouds, too many clouds there though, as I showed earlier. Okay, so most of this precipitable water is water vapor still. It hasn't gone into clouds. We're not seeing an ITCZ. It's too warm. It's staying as water vapor in the atmosphere, and it stretches across. And of course, the water can't go anywhere here. I mean, it's got to descend or move north or south. It piles up here, so we're getting this piling up here. and it's spreading out here. Notice this is spreading up here, which is also interesting. And what else is happening? Okay, so this is the ocean currents. So right here, you got about 1/2 meter a second ocean currents coming this way. You know, this is going a bit faster the other way. This is a normal direction. The trade winds come here, push the water. But notice it's fractured and it's vortexing and filamenting, and you know, here it's not. But you know, this is going this direction too. This is coming this. So we're getting water coming here, but it's very complicated and interesting patterns here with the water. But basically this here is carrying the warm water that's piled up here over across the ocean. It piles up against South America. We get the El-Niño. This is the air pressure, surface air pressure. So right here, you know, about 1010 millibar or hexapascals. You know, this is higher pressure, but not by much. Higher pressure, not by much. So generally that leads to these type of trade winds. You get coming this way, curving because of Coriolis, coming this way, curving, get the trade wind. So but that's not a very strong system. In a normal year, these pressure gradients will be slightly larger. You'd have more, the trade winds would be stronger. But the pressure gradient is weakening. We've also had these westerly pulses, at least 3 of them that Trenberth was saying, and that gets the ocean currents going. And this is just the winds at the surface. So you can see the southeasterly winds, but you get this area here where the water is coming across. So let's go back to the temperature. So, you know, what do you expect with the El-Niño? Well, you expect lots of flooding and rain here, and you expect drought towards south in Australia and Indonesia. Remember that big cyclone that went through high end? Well, the water was piled up 20 centimeters above normal. That contributed to it being so bad. So cyclone activity should be increasing over in this portion of the basin. Also notice this water is coming up, the warm water is coming up. So we could get some torrential rainfalls up in California and stuff, which, I mean, they need the rain, but if it comes down as torrential, it'll just cause flash flooding and, you know, it'll run off as surface water and go into soils enough, so it won't temper the drought. So it looks like all the evidence is pointing out that we're going to have a very strong El-Niño. So we've had this water being stored in the ocean since 97, 98, most of it staying there, and it looks like it could all be coming out. So much for that pause, you know, which isn't really real. We were undersampling Arctic weather stations since 98, but we could be setting, you know, if this El-Niño continues to develop quickly, we could be setting record temperature year for 2014. And you know, the effects of the El-Niño, generally, they won't start, you know, the big effects won't start till December of this year. January, February, March of next year could be pretty hairy. So we'll stop there, and I'll do further updates as the system changes. Thank you.